Yeah.
Okay, all right. So if you have x plus 3 equals 6 and you want to solve this one, well, guess what you're actually doing? If you were to graph y equals x plus 3, right? You know, that's what that looks like. Okay. And now, if you were to also graph y equals 6, okay, where those two intersect, so this is y equals 6, y equals x plus 3. Where those two intersect, okay, the x value where they intersect is the solution, okay? Now, when you solve this, it happens to be x equals 3, right? And so, yeah, like, so x equals 1, 2, 3, okay? So that's pretty much what you're doing. When you solve algebraically, that's what you're doing. So what we're going to do now is we're going to use that to do this, okay? To solve trig equations. So suppose you have this function now, this equation to solve. Cosine of x is equal to a half. Well, again, what you want to do is you want to graph y equals cosine x. Actually, let me write that in blue because it's graphed for us in blue. And then you want to graph y equals a half. Okay, so when I graph y equals cosine x, that's that blue graph. And when I graph y equals a half, that's that horizontal dashed line right there. And all the points where they intersect are the solutions to that equation. Okay? So where do they intersect? Let's see. The first time that we have an intersection is at pi over 3. X equals pi over 3. Does that make sense? Is cosine of pi over 3 equal to a half? Yeah. It is, right? Yeah. So that's the first time. And then what other time? And then look, when you go over a distance of 2 pi, you have another solution. When you go over this way, a distance of 2 pi, you have another solution. Okay? Another time where they intersect is at 5 pi over 3. And again, if you think about it, at 5 pi over 3, cosine is also 1/2, right? So from that, if you go 2 pi over, you have another solution. If you go 2 pi this way, you have another solution. So if you were to write all of these solutions, what would they be? Well, first we have pi over 3 plus 2 pi n. 2 pi n meaning you can add numerous 2 pi's. And then another solution is 5 pi over 3 plus 2 pi n. Okay, that's how we write them. And then you're like, wait, is it plus or minus? So we leave it normally as plus because we say n can be positive or negative integers, right? So that takes care of it all. Okay. So, okay, so if you take one other thing, if we take just one cycle from 0 to 2 pi, okay, how many solutions from 0 to 2 pi? 1 and 2, all right? But over the entire positive to negative infinity, it's got infinite number of solutions. Okay, so now let's go ahead with that in mind and solve one of them. To solve the following, the equations, you have to use algebra, okay, methods. Okay, and what you want to do is isolate the trig function. Okay, so here I have 4 sine x equals to 2 sine x plus root 2. All right, well, how can I solve this? I can subtract 2 sine x from both sides, right? So I can do minus 2 sine x, minus 2 sine x, So I have 2 sine x equal to root 2. And if I want to isolate the trig function, what can I divide by? 2. So I have sine x is equal to root 2 over 2. So now I have to ask myself, on the unit circle, for what values is sine equal to root 2 over 2? Pi over 4. But how many quadrants are there where sine gives you a positive value? 2. This one and this one. And if it's pi over 4 there, over here, it's 3 pi over 4. Okay? So, if it tells you to just solve the equations, you have to find all the solutions from negative to positive infinity. So I say, okay, it's pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n. Okay? All right. Yeah. No, x equals. X equals. All right, let's do one more. All right, here we have 3 cotangent squared x. Okay, so again, let's isolate the cotangent. First, I'm going to subtract 4 equals 3. Divide by 3, divide by 3. Cotangent squared x is equal to 1. Now, take a square root, take a square root. Cotangent x is equal to what? Fabulous, plus or minus 1. Everybody forgets the plus or minus. Good. So that means I have cotangent x equals 1, cotangent x equals negative 1. Okay? So now, on the unit circle, for what angle is cotangent equal to 1? Well, at pi over 4, remember cotangent is the x over the y, right? So you want the triangle where those 2 legs are equal. So that's the pi over 4. Where else is cotangent equal to 1? Positive 1. The third quadrant. So pi over 4, 3 pi over 4, 5 pi over 4. So this is pi over 4, 5 pi over 4 for this one. And then where is it equal to negative 1? Here. 3 pi over 4. So 3 pi over 4, 5 pi over 4, 7 pi over 4. Let me draw that to scale. Okay? All right. So 3 pi over 4, 7 pi over 4. Okay, now, what do you notice here? So you can write pi over 4 plus 2 pi, 3 pi over 4 plus 2 pi, blah, blah, blah. But do you also notice that it repeats more frequently at more regular intervals? How many degrees is there? This is a 45-degree angle, and that's the one. So how many degrees is there between those two? 90 degrees, right? And then so it's 90 degrees from here to here. How many degrees to here? Another 90, another 90, and another 90, okay? So between each of these, there is 90 degrees. That means this angle, pi over 4, like you have a solution starting at pi over 4, plus every 90 degrees, pi over 2n. Okay? So, if it's all of the pi over 4s, okay, so like that's going to be a thing. If the solution is all 4 pi over 4s, then it's pi over 4 plus pi over 2n. Okay? You just add pi over 2n. Okay? Because there's 90 degrees in between each one. All right. Let's do another one. Okay, here. Sine x cosine x equals root 3 sine x. What do you think? What would you suggest to do first? Okay. So I always want somebody to say, let's divide by sine x. Because, okay, so if we dividing by sine x is mathematically very correct to do. However, what that does is when you divide by the sine x, the sign goes away. And so now you've kind of like changed the problem.
Could you subtract it and factor it?
Okay, so that's what we can do. Let's subtract to this side and set it equal to 0. So 2 sine x cosine x minus root 3 sine x is equal to 0. Now, look at what you have here. You have one term plus or minus another term. This is a binomial, all right? In each of the binomials, you have a sine x. So what we're going to do now is we're going to factor out a sine x. Okay, remember, this is where lots of students run into trouble. Remember, in math, when you factor out a term, you're dividing each term by that thing that you're factoring out. Okay, so mentally do that. So now for the first term, what do you have? 2 cosine x minus, what do you have here? Root 3. And so now what you have is one thing multiplied by another thing equal to 0. So what I can do here is I can split it, and I can say sine x is equal to 0, and 2 cosine x minus root 3 equal to 0. Okay, so now let's think. Where is sine x equal to 0? 0. Sine is the y value. Where is it equal to 0? Here and here. Okay? So that's where it's, remember, sine is always the y value. So think on the unit circle, where is the y value 0? Here, y value is 1, y value is 0 again. So at 0 and pi. Okay, this one, I'm going to solve for cosine. So add root 3 to both sides. Okay. Divide by 2, divide by 2. Cosine of x is equal to root 3 over 2. Okay, so now I want to see where cosine is equal to root 3 over 2. Cosine is the x value, so I want the angle where the x value is higher. So pi over 6. And then where else is cosine positive? Here on the bottom quadrant. So this is 11 pi over 6. Okay, now take a look at the instructions. It had told us to find the solutions over the interval 0 to 2 pi. When it tells you that, you omit the plus 2 pi n. Okay, so the answers here are just 0, pi over 6, pi, 11 pi over 6. Most of the time, like when you see answers written down, they're in like increasing order. You don't have to put them in increasing order, but those are the ones. Okay. Oh boy. So what we saw here was that when you have trig functions on either side, you always want to bring it to the same side, right? You want to bring everything to the same side and set it equal to 0. Well, here too, bring everything to the same side and set it equal to 0. So I get 4 cosine squared x plus 2 cosine x minus 2 root 2 cosine x minus root 2 equal to 0. Okay. Now, how many terms do you have here? 4. When you have 4 terms, what I want you to do is factor by grouping. Okay. How do we factor by grouping? You're going to split it down the middle. From the left-hand side, I can factor out a 2 cosine x. And I have left, so if I divide by 2 cosine x, divide by 2 cosine x, I have 2 cosine x plus 1. Yes? From here, what do I factor out? Negative root 2 only, right? So if I divide by negative root 2, I get positive 2 cosine x. If I divide by negative root 2, I get, oh my God, plus 1. Yeah? Look at what happened now. I have 2 of the same. Okay? I write that off to the side. And then what do I have left over? 2 cosine x minus root 2 equal to 0. Cool? Okay. Set them each equal to 0 on their own. So 2 cosine x plus 1 equal to 0. 2 cosine x minus root 2 equal to 0. Okay, so let's go ahead and solve these. All right, I'm going to race you to them, and then I'm going to come and check. So at some point, this is what we have, right? And then where is cosine equal to negative 1/2? Well, cosine is negative in these two quadrants. And it's equal to 1/2 here. Remember that it's the angle which gives you a smaller x distance. So it's 2 pi over 3 and how much? 4 pi over 3. And here we want cosine to be positive root 2 over 2. So which angles are those? Pi over 4 and 7 pi over 4. All right, so those are the 4 answers. And if you wanted to put them in order, it's pi over 4, 2 pi over 3 in the second quadrant, 4 pi over 3 in the third quadrant, 7 pi over 4. Right? It's easiest if you go by quadrants. Okay? All right. Now, what if we have to use trig identities? Yep. Okay, so look at this one. You can use trig identities to solve these. So let's find all solutions here over the interval 0 to 2 pi. Okay, so look at this one. The first problem we have here is you have a cosine and a sine, and you can't really factor them out like the other one. Plus, this is a sine squared. When you see the sine squared, okay, you can, like, that should tell you Pythagorean identities, okay? So rewrite, so it's in terms of one trig function, okay? Trig function squared means Pythagorean identity. So look, I have a sine squared and a cosine. Okay, that like automatically leads itself to what? Sine squared x plus cosine squared x is equal to 1. Right? So what's sine squared x equal to? 1 minus cosine squared x. So 1 minus cosine x is equal to 2. 1 minus cosine squared x, right? We substituted that. Okay? Now, for a little while, the trig part will be over, and I'm going to do some algebra. Distribute. 2 minus 2 cosine squared x. Bring everything to the same side and solve. So, minus 2, and then plus 2 cosine squared x, plus 2 cosine squared x. So finally what I have is 2 cosine squared x minus cosine x minus 1 equal to 0. Okay? Everybody okay so far? Okay. Now, you guys remember how to factor quadratic functions? Yeah? You remember how to factor this one? Okay. Where is it? All right. You remember how to factor this one? 2x squared minus x minus 1. How would you factor that? You can, or you can do guess and check, right? So it'll be 2x, x, 1, 1, and then it's plus minus. Okay? Now, look at this. You have 2 something squared minus the something minus 1. Isn't that like what we had here? 2 cosine squared x minus cosine x minus 1. Right? It's the same form, except instead of the x, I have a cosine x. So I can factor this like this. 2 cosine x, 1, 1, and then plus minus. Okay? Now, I can solve each one of them, set them equal to 0 and solve. 2 cosine x plus 1 equal to 0. Cosine x minus 1 equal to 0. So 2 cosine x is equal to negative 1. Cosine x is negative 1/2. And this is just like the one we just did, right? So we just did cosine x equals negative 1/2 here. And we got 2 pi over 3, 4 pi over 3. Here, cosine x equals 1. Cosine is the x-axis. So on the unit circle, right, where is x equal to 1? Here. And that's it. So x equals 0. So those are the 3 answers. Okay? All right. Let's do another one. Bring everything to the same side. So I'm going to copy this over and then minus cotangent squared x minus 2 equal to 0. Okay. How many terms do I have? 4. This is one term. 2, 3, 4. When you have 4 terms, what do? Factor by grouping. Okay? So from here, I can factor out a cosecant squared x. And if we divide by cosecant squared x, I get cotangent squared x plus 2. From here, I can factor out just the minus 1. Cotangent squared x plus 2 equal to 0. Okay, so okay, so let's see what we have left. Cotangent squared x plus 2 times cosecant squared x minus 1. Okay, let's solve these equal, set these equal to 0. So here you get cotangent squared x equal to negative 2. Can you square something and make it equal to a negative? No, so that's no solution. Okay? Something squared can't be negative. But what about this next one? Cosecant squared x equal to 1. Square root. Cosecant of x is plus or minus 1. So take a look at C. Take a look at why there is a problem here. Why do you think there's a problem with C? Like if you look back to A, let's say. What's the problem that we had in A that we also have in C? Why? Okay, so the issue we had here is we had a sine and a cosine, so we had to write it in terms of, the other. Here we have the same thing. We have a sine, a secant and a tangent, two different functions. We want to make sure, and we can't factor anything out, so you want to make sure to write it in terms of 1. The problem, though, is the square and the top one helped us out, but this one isn't squared. So guess what we're going to do? We're going to square both sides. Okay? So when you square both sides, so here you get secant squared x plus the middle term, 2 times 1 times secant x, right? Plus 1 equal to tangent squared x. Okay, now secant squared x plus 2 secant x plus 1 equal to. How can we replace that with an identity? Let's go to the very first page. Is there an identity that we can replace tangent squared x with? I have a secant squared x minus 1. Looks good to me. Let's do it. Okay? All right. So now, what do we do next? How do we do that? Add 1 on both sides. So that goes away. What else? Subtract secant squared x. Oh, it cancels out. I'll take that. So 2 secant x plus 2 equal to 0. Well, that's a much better deal, right? So 2 secant x is equal to negative 2. Secant x is equal to negative 1. Which means cosine x is equal to negative 1. And if cosine is the x-axis, okay, so here x is 1. When I go here, x is 0. When I go here, x is negative 1. So this is pi. Okay? So the next one, this one, it's the same. You have a cosine and a sine. You have to square both sides in order to start. Okay? All right. Let's do this one. I love E. Love. You know why I love E? Is because there is 0 calculations, right? But you can't do it unless you really understand trig. That's an honors type question, okay? All right, so take a look at what this says here. You want the values for which cosine of pi over 2 minus x is greater than or equal to root 3 over 2. Okay, what the heck? So first, you say to yourself, wait a minute. Cosine of pi over 2 minus x. That's like a thing.
It's just like sine.
That's an identity, isn't it? Right? Remember, cosine of pi over 2 minus x? Those are the cofunctions. Where is it? Cosine of pi over 2 minus x is just sine x, right? So I can just rewrite that as sine x. Is greater than or equal to root 3 over 2. Why were we able to do that? The cofunction identities. Now, here's the biggie. For what values is sine greater than or equal to root 3 over 2? Well, let's see. Let's first figure out on the unit circle. Now, sine is the y-axis. Where is sine equal to root 3 over 2? For what angle is sine equal to root 3 over 2 the first time? Pi over 3. Good. Pi over 3. Okay? Why? Because at pi over 3, it intercepts the y-axis at root 3 over 2. Okay? So root 3 over 2 is like 0.8, right? So if this is y equals 0, y equals 0.5, 0.7, 0.8, that's root 3 over 2. So now, okay, so that's right there, y is equal to root 3 over 2. I want all the values for which y, so sine of x is like the y, is greater than or equal to root 3 over 2. So from here, okay, if I move down and if I have an angle here, okay, like pi over 4, am I going in the right direction? Is that a point where y is greater than root 3 over 2? It's not. No, went in the wrong direction. Got to go in the other direction. What about if I'm here? Is that a point where y is greater than root 3 over 2? Yeah. What about here? Is that a point where y is greater than? Here? Yep. Here, there is a point where it's exactly root 3 over 2 again. What's that angle there? 2 pi over 3. Past that, if I'm here, is y greater than or less than root 3 over 2 if I'm here? Less than. Okay, so with that green line, it looks like I pretty much had it, right? Like that's it. So the interval over which y is greater than root 3 over 2 is that highlighted interval, right? Those are, what are all the angles there? How can we describe all the angles in that interval? In between pi over 3 and 2 pi over 3. So you can either say pi over 3 less than or equal to x less than or equal to pi over 3, 2 pi over 3. Okay? And we do less than or equal to because we want also the angle where it equals root 3 over 2, right? So if this was just less than, I would have just used less than. So you can either write it like this, or you can say pi over 3 to 2 pi over 3 like this. So you see how there is no calculation, but you really can't do it unless you really understand what these relationships are, yes? And do you see why from the beginning of chapter 4, I kept stressing sine is the y value, cosine is the x value, sine is the, right? Like, because I'm from your future. I've been to where you're going. I know what you're going to need. So I'm trying to prepare you on the way. That's why when you tell me, let me just memorize the unit circle, I'm like, okay, so you can do these problems, but you can't do this. You know what I mean? Like, you have to have that understanding to do this. Okay? All right. So we'll stop there, and you can do your homework.